Electricity. Static electricity. Now this is a good time to remind ourselves about the structure of atoms. If you remember, we have electrons which have different energy levels arranged in shells or orbits around the nucleus. You've got 2 in the first shell and a maximum of 8 in any subsequent shell. And remember, in the nucleus we've got protons and neutrons. Again, just as a reminder, an electron has 1 negative electrical charge, a proton has 1 positive electrical charge, and neutrons are uncharged. Now, this is revision again. The number of protons in an atom is always the same as the number of electrons, and therefore the charges cancel each other out, and the atom has no overall charge. Now, if an atom gains or loses an electron, then it gains or loses a negative charge, and we call a charged particle an ion. Now, certain insulating materials can become electrically charged when they're rubbed together because the electrons are rubbed off. And when this charge builds up, in other words, when it doesn't flow, then this is known as static electricity. Static because it's stationary, it's not moving, it's not flowing. Now, conductors don't build up static electricity because, by their very nature, they conduct it away. Now, a lot of exam questions refer to polythene and perspex. Now, if you rub polythene with a dry cloth, this transfers electrons from the cloth to the polythene. So the polythene becomes charged. Now, does it become negatively or positively charged? Electrons go from the cloth to the polythene. Well, electrons have a negative charge, don't they? So negative charges move from the cloth onto the polythene, so the polythene becomes negatively charged. Now, perspex behaves differently. If you rub perspex with a dry cloth, the electrons are transferred from the perspex to the cloth. So the perspex loses negative charges. So the perspex becomes positively charged. Now, opposite charges attract. So the charged polythene and the perspex attract each other, but like charges repel. Now, current electricity, as opposed to static electricity, electric current is a flow of charge or a flow of electrons. Now, metals make good conductors because they consist of delocalized electrons moving in a lattice of positively charged ions, and these delocalized electrons are free to move. Each electron carries 1 negative charge, and each electron carries energy. Now, the energy is transferred to the component that the current flows through, for example the light bulb, and the bigger the current, the greater the rate of flow of charge. Now, charge is measured in coulombs, capital C. Current is measured in amps, capital A, and a current of 1 amp is equal to 1 coulomb of charge passing a point per second. Now, you'll find this equation on the physics equation sheet. I equals Q over T. Now, this is where I, which is the current measured in amps, is equal to the charge measured in coulombs divided by time in seconds. And there's a triangle, Q over I times T. So have a go at this. A charge of 5 coulombs passes through a light bulb in 2 seconds. What's the size of the current? So use the equation above and then check your answers upside down. Now, electrical circuits need energy to push the electrons around the circuit, and the energy is provided by cells. 2 or more cells equals a battery. We tend to call each one of them a battery, but actually one of those things that you put into the circuit is called a cell, or it's provided by mains. And you're expected to be competent at drawing circuit diagrams. You're expected to know all the symbols that you'll find on the next page, and you're expected to be able to use them in simple circuit diagrams. So you're expected to know these symbols, so you need to learn these off by heart. How about printing off 2 copies of this page and then cut off the labels from one of them and then name them all from memory?